So, hello, ladies and gentlemen. I'm Christian Gosset from Gosset Tech Tapko in France. I have my own company in KNX Technologies for 7 years, and I'm part of the Tapko group. I'm in KNX Technologies since 20 years now, and I have some expertise in easy configuration, and mostly in KNX RF, with some also specific development in software for energy harvesting devices. I will today focus the webinar on some very interesting solution using KNX RF technology that has been used in emitter radio LINKY, some words in French because the project has been done in France. Which is the radio emitter in the LINKY meter. Some terms that will be used in this presentation. We will speak about LINKY, which is a trademark from the Enedis company, which is the name of the electricity meter in France, the new one. We will also speak about RF, radio frequency. We will see some words like TIC, Teleinformation Client, that's the communication protocol coming out the meter. The plan of the presentation will be a short introduction of the project to see how we use and introduce KNX technology in the meter. Then we will go through basic requirements from this module. Some parts moving from the ERL to the KNX, how to translate or to transmit information from the meter to the KNX world. Then some information about the project. And at the end, some information or features for the stacks that are be used for KNX configuration, easy push button, for RF multi and data security. And at the end, to finish, some outputs of the project and some information on development solutions. So the project or the idea to have a connected electricity meter started in June 2015. It was in a grid fair, a smart grid fair in Paris. And some company decided to specify and make a first project to be able to transmit by radio some information from the electricity meter. It was started with the French company ERDF, which is now Enedis, and based on the smart meter LINKY. One big information is that the LINKY smart meters will be replaced in France between 2015, it has started already, on 2020. Maybe it will take 2 or more additional years. The meter. So the ERL, the module that will be linked to this meter, will make a link possible between the meter and some appliance in building automation. Today there is foreseen a lot of things like electricity boilers, heating systems based on electricity, and also a lot of information to be displayed to the end user about the consumption. The amount of meter is a very big amount. That is 35 million meters to be deployed, but not all meters will be use an ERL. And as it was a device or a project defined with multiple manufacturers, the 2 protocols are mandatory in the device, in the solution, KNX RF and ZigBee. You can find some commercial or project information on the website from the Smart Electric Lyon. So some market requirements from this module, the ERL, it shall bring new services to the customer. First point is to bring good tariff management. We all know that in the future there will be multiple tariffs to have the best prices and also the best producer source of energy to be used for every people. You need also new interaction between user and energy provider. If there are some peak to be avoided or other things, you need to interact with the end user to get his acknowledgement that we can make a peak avoidance at this moment or not. Fourth big point is to display the instantaneous consumption production of electrical energy. I always explain the main role of energy reduction or to reduce the energy consumption is the habits of the user. And for this, you have to see what is currently consumed. Like when you are driving your car, you have your gas consumption displayed on the computer. The fifth point is to drive some equipment for energy optimization. That what is behind this is to have some possibility to connect boiler, electricity boiler on electricity heaters or cooling systems, and to use the best tariff or the best period of energy to have the same comfort as before. Peak avoidance and load shedding, this is also to be able to display when there will be peak or shedding phase. And demand response and request is mainly also to be displayed to the user to accept or not some changes from the provider. On the right, we have some information about the agenda of the project. So it starts at the end of December 2014 with previous specification, and to be finished mid of 2016 to have the first prototypes available from the manufacturers. So to have a look and to have some pictures, what is the ERL and what is the meter, we can see on the pictures we have 1 meter, which is equipped with a small place which has been reserved for some devices, and one of the first devices to be connected to the connector with 3 pins. So we have the 2 pins of the TIC, and we have 1 pin with power supply. So the ERL is powered by the LINKY meter, and we get information from the TIC. The direction of communication is always from the meter to the ERL. We have no interaction from the module to the meter. What we can also see on the pictures is that we have remote devices which is linked to the ERL to make the push-button configuration, because when installed, the ERL module will be under another cover plate that will cover all the meter on the ERL, and then we have no more access to this module. And to be able to make the push button configuration, we need remote HMI. From the technical requirement, there are 4 requirements about communication. The communication must be radio frequency, so between the ERL module and the home network. The ERL must be a radio transceiver, that means it can be able to transmit and to receive. The commissioning, so commissioning means establishing linking links between the module and the home network, must be done without tools. The RF communication must be secured, authentication and encryption. And for this, KNX has been chosen to be one solution for this. So today, if you want to develop such a module, you have to use KNX RF with easy push button configuration to fit all the technical requirements we have seen in this page. Some project inputs. So the project, as I said before, was started and managed by SEL Lyon, Smart Electric Lyon. And the goal was to deliver 40 prototypes based on KNX current specification. I will explain after what means KNX current specification. And these prototypes has been delivered to be installed and distributed inside the manufacturer of the association, so the SEL association. At the beginning of the project, only one provider of KNX stack was available on the market. It was the KNX stack from Tapko, which was already using push button mode, RF multi, and security has been developed specially for this project. So we will now switch to the way to come from ERL specification to KNX specification. What we can see is that we have official ERL specification. You can normally download for free on the Smart Electric Lyon. Maybe there are new releases since, I think, in 2017 have been two new releases. So we see one requirement in this specification is ERL must be able to communicate with automation devices using KNX protocol. The standard to use is KNX RF multi. That means RF multiple frequency with fast acknowledgement. That means with handling of layer 2 acknowledgement to be sure that the devices have received all the telegrams, even in group communication. And this is done on frequency 868 with the multiple multi-channels, RF multi-channels, and which is named in KNX RF1.m. RF1 means 868 and M means multi. So just a small description from the official specification. The ERL is an electronic device to provide the information from the TIC to any devices from the building automation system. So that's what I already explained in the slide before. Now, in the same topic, we can see that already in the ERL specification, a lot of KNX references to different parts of the handbook are detailed as a reference document to be used when you implement or you develop such devices. Two first documents are the description of the TIC, tele-information. You will see all the fields. It is basically a serial communication with two modes. One mode is the historic mode, which is the slowest mode at 1,200 baud, with some limited fields, information about the meter informations. It has a monophase case and a three-phase case. The second kind of communication TIC is the standard communication, which is quite more recent and which is based on 600 bauds, and which has more detailed fields in the protocol and more information, and which is also able to manage producer or consumer aspects of the meter. Then we see a lot of KNX document references. We first have the configuration procedures that are all the push-button procedure. We will stick to all the KNX data point types for interworking. And then we have the KNX radio part for the RF multi-specification. And as for all KNX devices, we always have the KNX system conformance testing definitions. Additionally, we have three application notes that are currently available on the standard, which is the KNX data security, which will be used for the secure part. We will have the RF mode profile. We will use the metering M-bus data collector, and we will also use the AN169, which is the push-button mode secured configuration. So from the ERL specification to KNX specification, you have directly the link, and then we can start the project and the development. The project, just to show what has or what was developed in the project, we have three devices. The first device is called in this presentation ERL sender, which is the module that will be placed in the meter, which will get the TIC signal and will send information to the RF world, and will also get some request on data, and will make some curve data logging and so on. The ERL remote devices, which is linked to the ERL sender, and which is very simply said, it's a remote interface of the module, because the module will be plugged in the meter with the, which is after this covered with the screen plate, and then the remote devices will have one LED two LEDs on one push button, on which will act as the interface of the module. The last device we will speak about is called ERL Gateway. It is the module that will be able to receive and get all information from the ERL sender. So it will be linked with the sender using push-button procedure. It has also, in this case, a USB serial interface to be connected to a Windows software, so that we can display the data. We can have more friendly interface to make tests with the ERL sender. We will be able, with the gateway, to make data requests. That means while you read, to get some data that are not automatically sent from the meter, and we can also access to some properties like application parameters or array of data logging. Some indicators on the project and some remark. The software development is done or was done for EDF on SEL members with OMWave company that makes the hardware on the ZigBee part. GTT Tapko, so my company, has made the KNX RF multi-push-button stack and also all the ERL channel application development, introducing the security in the stack during the project. So the main challenge at this time is to make a stack development with moving specification. That means you implement new features that are still discussed in some working group, but it has a very good impact on the specification. It helps to find and fix open points in the specification. That means at the end, the specifications are very well and can be voted in the KNX groups on KNX voting cycle as a good implemented solution. It's not only papers, it has been implemented, tested, and then you have very good solutions. So just a reference to the documents, the specification involved in this project that were under design. It was the AN169, AN158, and 179. The two other documents are still established and approved standard, as we see. And we will see there are quite some new data points in the channel from the ERL, because we have new data to be transferred from the meter to the gateway. So now we will go to the specification or some details about the application that is in the ERL sender. So the ERL application, as it was defined initially in the SEL specification, the first and main issue is to handle the TIC. So the tele-information client must be decoded according to the two standard, historic and standard mode, and you have to extract all the fields from the frame to be adapted or mapped to KNX data points. You have also some local averaging or time stamping of data. That means there are some additional data points that were requested from ERL and for the regulations. And for this, they are not time-stamped or average in the TIC, and so the module has to do this additional job. You must be able in the application also to push data according to some timing requirements. You have to provide it some data on request, and at the end you must use data points. Just to have an indication of how big is the channel, we have an easy channel with 99 data points. Normally, an easy application for lighting, as an example, will have, I will say, up to 10 data points. So it's quite a huge application with a lot of data points. We can see some details of some data points. I will not go through all the list, but you have some apparent power. N-1 means from day before today, from yesterday. You have some voltages of the phases, which is time stamped. So we have one data point with 3 voltages for the 3-phase meter, and so on and so on. And then we have the definition of the channel TIC, which will be the list of data points with data point types and connection code to be used for the push-button configuration on the connection rules. So that's the type of data point, and the data points with the corresponding connection code will be linked automatically during the push-button configuration. Today, the ERL application has evolved in some specification. What we have today, we have some evolutions to have better data integrity. That means some data points have been concatenated, especially some counting indexes, because they are making no sense to be sent individually. They must be concatenated together to have the main signification. There are some details on the date-time handling, because the curves on the data will be time-stamped. And it's important to know the clock quality. If the clock is coming from the meter itself, it's high quality because it's directly linked to data. If you get clock from KNX devices that is not synchronized with any internet clock or any other good clock, you may have a clock quality that is not the highest, and it must be set in the timestamp that the dead time is not with the highest quality. Some dedicated or some more precise information about tariff management, that's more tariff namings on what is going on with the different information. A lot of details about curve table content. We have some dedicated data that are mandatory from the regulation to be able to see the power curve on the energy curve. Information important, the duty cycle management, because we have in this device regular sending, cyclical sendings, and you may reach the duty cycle of the RF specification. And for this, it has been specified in the application how to react to this duty cycle limits. The last, and also important, is introduction of some functional parameters that were before fixed in the specification, and that becomes parameters. Some change of value, that's the parameter that specifies the difference between the preceding value and the current value to decide if we send or not a data point. We have also the cyclical time for sending and some information on dynamic mode. And today we have an ERL easy channel with 104 data points. So after the ERL application, we will now go through some KNX push-button stack information. So we always, when we speak about KNX software, we have two parts. We have the KNX stack, which is all the services and all the protocol and services features that are used in the standard. And then we have the application part, which is using all these KNX stack and interfaces and services, but which is standardized from the interworking part. So we have seen the application part from interworking, and now we are looking the system part from the KNX stack. KNX push-button secured. We have one specific part for security in push-button, which is the generation of security key for making the configuration and to also generate runtime keys for security. And it is based on the ECDH, so elliptic curve, Diffie-Hellman. And today there are some open source stacks like the Relic one, which takes approximately 27 kilobytes on the MSP430 or 23 kilobytes on an ARM Core M0. It's a little less on M4. This part is used to generate keys with the process of Diffie-Hellman, which is with private and public keys, on an asymmetric exchange of things. It's not so time consuming when you generate the keys, but it's code consuming. Then we have, for the push-button configuration, it has been specified two basic things. One is called the basic push-button configuration, which is only based on pressing buttons. That means you press the programming button on the device on the sender, for example. Then you press the push button on the actuators, and they are establishing the links with all the security based on the algorithm we defined just in the chapter before. We have a second way of linking push-button devices, which is called the enhanced secure push-button configuration. But this requests to some interface to enter the factory default security key. It's like if you have your Wi-Fi box and you enter your Wi-Fi key in your smartphone, and then the links are established. It's exactly the same. And this is used in this project mainly because one of the first devices that will be provided with the ERL will be a graphical display. And then it will be very easy to enter on this display the FDSK of the ERL to make the first link. The secured, so that's not so new, but it's a new feature that must be added to the stack to be compliant to this enhanced secure push-button configuration. Then we have in the security, we need sometimes to synchronize the security sequence number. If you are making some links or destroying some links, deleting some links, excuse me, or maybe you have a device, receiving devices, it's a mobile display, and it's not always synchronized with the ERL. When you make a request from the display to the ERL, you will need to synchronize the security sequence number. It has been introduced in the data security, and it is available in the KNX Push-Button stack. One next big requirement for security is that you need to store the security sequence number in case you are losing power supply, or you make some updates. So for the ERL module, we have chosen to use an EEPROM emulation in Flash. And if you have more device linked to the ERL, you need a lot of Flash for this EEPROM emulation. One good solution is to use, if you are in the MSP430 world, to use the new FRAM MCUs, so you don't need to make a special software for this. And the second part is to have very good power save capabilities of the device. So if you don't want to always write in the flash, you can have a power save signal and save all the counters, sequence numbers when you get the power save. At the end, when you want to test and to check new features using security, you must have some dedicated testing keys that are compiled specially for this, and then you can use EITT, the new version. So EITT is the official testing tool from the KNX Association, and it has also been adapted to be able to display and to decode secure frame. Next point I will show is from the KNX RF multi, some requirements, because we say we use the KNX RF multi-frequency solution, and just to, I will not enter in details how it works, but there are some requests or some constraints on the different hardware. One of the main constraints for the hardware is to get a precise 1 millisecond tick, because the AX slots are defined for fixed time slot, and we only have allowed 0.1 milliseconds deviation for 64 milliseconds. That means either you have a good 32 kilohertz quartz on your board or on your device, or you have a good oscillator in the RF chip. It can be both, or you have a good oscillator also on your board. The second point is today KNX RF multi can be implemented on a lot of RF chipsets. But today, if you are just doing RF ready things, you can use mainly the packet handler of all RF chipsets, which is compliant to MBus solution, which is the same physical layer as KNX. And you can use a normal packet handler even if you have some specific issues about the variable length on the CRC topic to be handled, especially in packet handler of the RF chipset. The fast stack is a very small packet that is sent in the AX slot just after the sending of the telegram. So the sender will send the telegram and will allow some time slot to get the acknowledge for each receiving devices. And this fast stack has a specific format that is not compliant to all packet handlers. That's why I say they are not fast stack friendly. But you can still use them, but then you have to switch to raw mode or direct mode for some of them to be able to send and receive these fast track packets. The third issue you may have as or to be worked in detail is the frequency shifting for RX scanning. Not to write always all registers, but only to write what is needed, because the writing of register is an amount of time that is requested to the chip. And also you have to remember that when you change registers, the chip needs sometimes to go from idle to RX, PLL synchronization or other things. And this time must be also less than 1 millisecond. Because you have 1 millisecond scanning, 1 millisecond for switching, 1 millisecond for scanning, 1 millisecond for switching. So this is these are the three main points you have to be aware when you go to RF multi implementation on a new RF chipset. Last part on the KNX stack Push-Button is about the configuration, secured configuration. One issue you must be aware is that the new version of configuration is always compatible with old procedures. That means you have to embed also the old configuration procedure, which are not very different, but are using less services. We have for the ERL a new possibility for efficient linking that is now mandatory, because in the new channel we use connection codes in the extended range. With the preceding push-button configuration procedure, the connection code was limited to 8 bits, and as we have now a lot of connection codes defined and we must go to the extended range, more than 8 bits, we use efficient linking. So it's new services in the push-button procedure that allows connection code up to 16 bits, and that also allows to make multiple linking in one step. Before, when you want to, with the old procedure, when you want to link 2 data points, you have to use 2 telegrams. 1 telegram for linking the group address of the data point, and 1 telegram to exchange the RF multi-features and the security features. Now, with 1 telegram, you can make up to I don't remember, but I think maximum is 20 links in one frame. So for our project, now it's a very big improvement, because as you have seen, we have 104 data points, and we are able to link the 2 devices in 10 telegrams. And the full linking of KNX channels is now reduced from 40 seconds to 10 seconds with the K generation on all the parts. Last but not least, in the KNX Push-Button stack for RF multi, we also introduce a specific mechanism for the handling of missing devices. If this is the case when you have made some links between a sender and sensor on an actuator, and the actuator is not more available, the sensor will send the telegram, will wait for the AXLOT, and if the AXLOTs are missing, will send up to 3 retries of the same telegrams to get an answer. And this will be the case every time he wants to send something to the device. So it's not a good solution for the duty cycle problem, and that's why we introduce, or KNX introduce in the specification, this new part, which specify firstly the sequence of frequency to be used. So send on frequency 1, send on frequency 2, send on frequency 3, then go back to 1, to 2, to 3. It also specifies the number of retries. It means the sender will make 1, 2, 3, 4 retries. If I remember well, it is 5 retries in the specification. And then we just have a blacklist for missing fast stack. That means if the actuator has not answered to the telegram, it will be put in the blacklist. And next time we don't get fast stack from this device, we will not do a retry. If the device answers again, it will be removed from the blacklist. So it's a good mechanism to reduce telegrams, repeated telegrams for nothing. And then the last modification on the stack that is necessary for such a project is a around this duty cycle issue. And as the duty cycle is important, it has been necessary to add new events between the application and the stack. And I just put the table of some restriction according to the current duty cycle to the application. We can see if the duty cycle is minus than 75%, you can have all runtime transmission on alarm. That means you can make all requests, all dynamic mode you want, all the things you want without restriction. Then second case, you are under the 90%. The dynamic mode, which requires more telegram, is not more available. So according to this, the end user or the display is not more able to activate the dynamic mode. If you go to the next step, you have more restriction. And if you are at the limit, that means 98%, we only transmit alarms, and all runtime information are not allowed. Linked with this, we have also a new data point that is used to be sent by multicast to all receiving devices to say and to inform the value of the duty cycle of the device. So we have now done or passed in review all the modification on the requirement on the stack, and now I will present you quickly the result of the project. So we can see some boards. So that's the ERL module with the 3 connectors to be linked to the meter. Then we have the remote devices, which has 2 LEDs on the one push button. The battery is on the back. And this is Tapko evaluation board with A61211 RF module. We can see the MCU and we can see the USB interface to be connected to the PC, to the computer, to Windows. On the Windows applications, it's a very technical application for developers that can be used to see all the data point values. You can make a request, you can get the values, then it is decoded. You can see the KNX value that is in the frame, and then you can also see the decoded value according to the data points and the data point type, the type of the tick, historical standard. We have a small trace in the application, so we can see the progress of the link. This is the old linking procedure with not the efficient linking, so you can see each step of the linking. We have a small display or hard copy of the interface using the security key, so you can enter your FDSK there, and then you can start the linking procedure with the device which has this security key. And we have also some interface to start standard security linking. Some other technical output from the project. The result is a KNX RF easy multi-secured stack. So we have all the features in the title. And this is a dedicated combination of the full modular S-mode Chi stack. In order to be very fast in the development and to have a quick solution, it was decided to make a dedicated solution for this, and it will be put in the full modular S-mode stack now in the next month to be available as a standard solution by Tapko. It is running on FreeRTOS. You may know it as an open source, or for the Renesas solution with Fredix. We use Eclipse on GCC or ERL, supporting some MCU targets, MSP430, Renesas Synergy S1, S7. As RF chipset, we have implementation from Semtech SX1211 or on Lapis ML 7345, or also some solution on SOX, on semi small SOX. It's the AX80 72, not 71, 72 F143, and also on the Scilab's EFR32, the FlexGecko solution, FlexGecko versions. Some feedback from the project, from experiment. There is one big challenge in this project, which is the power supply according to the RF performance. We have, it's not translated, but we have minimum 130 milliwatts available under 6 volt. So you can imagine what it is. It's like energy harvesting, and then you have to have some good optimization on the hardware especially, and also on the software to be able to get the solution for this meter. The second thing, which is also linked with radio frequency, is that the smart meter in electrical box is maybe metallic or outside the house. You have sometimes the meter which is in the street. And for this, we have seen that we have advantages on the RF part from KNX, because firstly on the frequency, and also yes, the frequency is more going through walls on cellar in the house. Update of the firmware is foreseen by LINKY. It is already included in some ZigBee specification, but we have also some possibility or implemented solution from the KNX side. That means we're able to update all the application, even the ZigBee part from the KNX side. We have some good result on the KNX. It requires sometimes to make the update, but it runs even if without reducing any services of the device. That means you continue to work with all KNX telegrams, and we add additional telegrams to make the OTA. Next steps for the project will be the certification of all of this. So we have 2 new physical layers to certify, the Lapis ML on the Scilab's EFR32. We need to certify all the KNX Push-Button security solution, the new services from the Push-Button, and one big topic or one big work will be the interworking test for the easy channel, because we have now 104 data points. Some commercial aspects. Today there are some demonstrators available on Tapko Eval board and Tapko RF modules. Lapis, so it's a company, Lapis ROM, has also some modules using own ERL modules that fits directly in the box. They have also the ERL remote module that fits in the box. And they have done RF gateway module, also a very small one that can be used for demonstration or development. The third is the Synergy software development kit from S1 and S7, which are using eval boards from Synergy, Renesas, and Tapko RF module. From our side, we will provide the KNX Push-Button with RF multi-secure stack. We will help manufacturers to migrate from electrical appliances to KNX devices. That means some boiler, electrical boiler companies which want to be connected to the meter. We can help them to develop devices. We will also provide USB RF sticks for RF multi and secure communication. And the last one will be a USB RF stick, which the ERL gateway application to be used on any box or gateway. A small description of the Tapko Lapis solution. So we have some demonstrator based on eval boards, but we have also on Lapis has some eval boards based on devices like we can see. One good issue with this Lapis chipset is that he has very good packet handler that can be used also for fast stack on RF multi very easily. So the chip has a very good packet handler. So just to see the eval boards, some pictures of the Renesas eval board. So you can see the two eval boards with the RF module. Some graphical application to make first a KNX stiffer, so you can see all the KNX telegrams. You can see the KNX, the ERL data, excuse me. You can make the linking, and you can also unlink the device. And the software is proposed on the E2 Studio from Renesas. The last solution is what we have using EAR on the MSP430 A61211 is with two, always based on this board. We can have the ERL sender, the ERL remote, and the ERL gateway with some limitation in functionality, sure, as demo version. And then you can evaluate or test the application with these kits. The future of this will be to mix, as I say you before, to go back to merge it to the KI stack and to have the mixing of push-button mode plus S mode, because the next roadmap issue will be also to have an S mode implementation to be able to link the meter in ETS. Second thing is to add additional diagnostic data for the RF stack, as we have already in the S mode stack with some ETS applications that are able to display RF information. That must also be the case for push-button devices. And last but not least, a new stack architecture to be split, for example, because the device needs to use ZigBee on KNX, and to be able to use a big MCU and link the ZigBee stack, and a small SOC or an external transceiver to manage the KNX protocol. So you have seen we have quite finished now. Thanks for your attention, and always think you have ideas, you have product. We don't think it's impossible, so we do it.
Thank you very much, Christian. Definitely very interesting from the KNX RF development point of view, but also the business case is exceptional. Such a deployment of KNX at such a large scale is definitely very good for the business to gain traction, and it's been very useful information. I don't know if there is any question from our participants. Now it is the time. Of course, I believe they can always reach you by email. Yes. So if you want to put it on the chat box. But also, it's time for your questions. So any question, please, you can use the chat box as well. It's a good moment now in case you have any particular question. Thank you very much for the email address, which is now there for anyone. Any particular question? That means that was very clear, Christian. That was very clear. So it's definitely a complex topic, and I believe that the information was well received. Okay, no particular questions. Well, I will stop the recording now.